Variables are fundamental elements in programming languages, including Python. They act as containers or placeholders used to store and manipulate data within a program. When you create a variable, you allocate a space in the computer's memory to store the data associated with that variable. You can think of Python variables as storage containers in your kitchen. Every container or variable in Python has the capability to store various types of data values, much like different kinds of food that can be stored in storage containers. For instance, a variable can hold delicious fresh vegetables, some fruit, a slice of cake, or leftovers from dinner as its data value. Similarly, just as you would label your storage containers to distinguish their contents, in Python you assign a distinctive name to each variable to indicate the type of data it represents. This naming convention allows for easy identification and retrieval of the stored information within the program. Similarly, when you wish to retrieve the food at a later time, you look for the storage container marked with the corresponding label. Likewise, in Python, you can refer to the data values by simply referring to its associated variable name when you need to make use of it. Furthermore, the size and shape of foods inside the containers can differ depending on what you are storing. Similarly, in Python, the types of data that a variable can hold, such as numbers, text, lists, and more, can also vary. The flexibility in the types of data a variable can accommodate is akin to the diverse sizes and shapes of storage containers, allowing you to store and manipulate different kinds of information efficiently within your program. In Python, you have the ability to modify the value stored in a variable, similar to how you can change the contents of a storage container. This dynamic feature of variables makes them an indispensable component of your programming toolkit, much like storage containers are essential for organizing your kitchen. A thorough understanding of Python variables is comparable to honing your skills in arranging your kitchen with storage containers. It is a fundamental aspect that ensures your code remains organized and efficient. To summarize, variables play a vital role in data manipulation, performing calculations, and maintaining information within your program. They are a fundamental concept not only in Python, but also in programming as a whole. Consequently, acquiring a solid understanding of how variables function is crucial as you advance in your coding journey. Now let's explore the process of creating a variable in Python using the assignment operation. Now that we have gained a clearer comprehension of variables, let's embark on a culinary adventure in our Python kitchen. The initial step in utilizing our Tupperware containers involves filling them with delectable food values. This procedure is referred to as creating and assigning variables. Similar to how we place different ingredients into separate containers, we assign diverse types of data to distinct variables. Once these assignments have been made, we can employ the variables in a multitude of ways within our Python programs. So let's roll up our sleeves and dive into the process of creating and assigning variables in Python. We could easily create or assign a variable by choosing a name for it and assigning it a value. The assignment operator is represented by an equal sign, which is used for this assignment process. Here is the base syntax of a variable assignment. On the left side of the equal sign or assignment operator is the Python variable. You can choose any valid name for your variable, following the Python naming conventions. For now, I simply called it variable for demonstration purposes. We will cover more on the naming of variables later on in this chapter, but for now, simply remember that it should be descriptive and meaningful to represent the data it will hold. On the right side of the assignment operator is the value. The value can be a specific data value, an expression, or even the result of a function. We will look into various types of values you can store in this and the next chapters. I also mentioned the word syntax earlier, so let me quickly define its meaning. Syntax is like grammar for programming. It dictates how the language is written and read, much like any spoken language such as English, which has grammar rules that we need to follow. Using this syntax, we are telling Python that we want our variable or Tupperware container to hold a certain value, such as a food item, in our kitchen. Let's now create our first custom main variable to better illustrate this. First, we need to create and type a name that we want to give to the variable. For this example case, we will simply call it Tupperware, as it refers to the Tupperware container in our kitchen. Next, we type the assignment operator, otherwise known as an equal sign. On the right side of the assignment operator, we need to assign a value. In our case, this will be the food within the variable or Tupperware container. To do this, we first type double quotation marks followed by a food. Let's go with carrots for this one. Then we simply close off with another set of double quotation marks. To recap, in this example, Tupperware is the name of the variable and carrots is the value we're storing in it. In other words, We just told Python to put the carrots in the Tupperware container. Just like in a real-life kitchen, where we can open the lid of a Tupperware container to see its contents, in Python we can achieve the same by using a print statement. In Python, statements are integral to the language, and the print statement is among the most commonly used. Its purpose is to display or access the data values stored in variables, much like the carrots in our Tupperware container. As a Python coder, you will encounter and employ the print statement regularly, so it's beneficial to familiarize yourself with it. To utilize the print statement and reveal the contents of our Tupperware container, we would follow these steps. First, type the word print, followed by an opening parenthesis. We would then type the variable or container we want to access, which in this case is Tupperware, before finishing off using a closing parenthesis. We can run this code by pressing the play button, or by simply pressing Ctrl+Enter on our keyboards. Python will output the value inside the variable, or in our case, show us that we have some delicious carrots inside our Tupperware container. That is how easy it is to access a value within a variable in Python. I will be using the print statement a lot during this course, so don't worry if you don't understand it just yet. You will soon enough. As with any kitchen, we naturally will have more than one Tupperware container for all the delicious food we want to neatly store and keep fresh. Python allows us to do that as well by being able to create as many variables as we want. For example, we can have the following 5 variables or Tupperware containers, each holding a different value or food. We can visualize this as 5 different Tupperware containers, each containing a different food item, including carrots, apple, tuna, cake, and pizza. You can see that each variable has a unique name and stores a unique value. Now, whenever we need to use any of these food items in our program or in our kitchen, we simply refer to the appropriate Tupperware, again using the print statement. For example, if we want to know what's inside the Tupperware 2 container, we would simply type print, opening parenthesis, Tupperware 2, closing parenthesis. Pressing Run or Ctrl+Enter again will tell Python to output the code, resulting in the word apple. We can also access multiple foods or values within different Tupperware containers or variables, by simply using a common separation between these within the print statement. For example, if we want to see what's inside the Tupperware 3 and Tupperware 4 containers, we would simply type print, opening parenthesis, Tupperware 3, Tupperware 4, closing parenthesis. This time, Python will output the words tuna and cake when we run this code. Until now, we assign each variable and value on a separate line. However, we can also assign multiple variables and their associated values simultaneously in one line. Here's the syntax for multiple variable assignment. On the left, we will have all the variables as variable 1, variable 2, and variable 3, followed by the assignment operator, then the associated values as value 1, value 2, and value 3. Note that this isn't limited to only 3 of each, as you can add as many as you like. Creating your variables and values this way is like filling several Tupperware containers with different types of food all at once. Here's how you can do this in our Python kitchen. Tupperware 1, Tupperware 2, Tupperware 3, Tupperware 4, Tupperware 5 equals carrots, apple, tuna, cake, pizza. In this line of code, we're assigning 5 different values to 5 different variables in relation to their order. Here, Tupperware 1 holds the first value, which is carrots. Tupperware 2 holds the second value, which is apple. Tupperware 3 holds the third value, which is tuna. Tupperware 4 holds the fourth value, which is cake, and Tupperware 5 holds the fifth value, which is pizza. The result is exactly the same as previously, which we can see when we again use the print statement. As you can see, we get the same output result of tuna and cake. Therefore, the only difference between the two methods is that this was done in a single line of code, while the other was done by assigning each variable a value on a separate line. It just comes down to your preference and how you better visualize your code. I personally prefer the first method of multiple lines, as it makes it easier for me to quickly see which value is assigned to which variable, but in the end it's up to you which one you prefer, as both are acceptable. Awesome! Let's move on. In Python, you can also perform chained variable assignment, which allows you to assign the same value to multiple variables in a single line of code. This can be useful when you want multiple variables to have the same initial value. Here's the syntax for chained variable assignment. Variable 1 equals variable 2 equals variable 3 equals value. In this case, all 3 variables, variable 1, variable 2, and variable 3, will be assigned the same value. Now, Why would you want to do this? Imagine you're planning to prepare a nutritious vegetable soup later in the week. You've bought potatoes, peas, and broccoli, each for their distinct flavors and health benefits. While you could store these vegetables separately, each in their own Tupperware container, there is no point, as all three ingredients are going to be mixed together in the soup anyway. Therefore, it's logical to chop them up and combine them as mixed vegetables instead. However, while chopping, you quickly realize that there are now way too many mixed vegetables to fit into one or even two Tupperware containers. You're definitely going to need to store all these mixed vegetables into at least 3 separate Tupperware containers. In Python, you can represent this scenario using chained variable assignment. This is a handy way of assigning the same value to multiple variables in a single line. Here's how you can do this. Tupperware 6 equals Tupperware 7 equals Tupperware 8 equals mixed vegetables. In this example, all 3 variables, Tupperware 6, Tupperware 7, and Tupperware 8, are assigned the value mixed vegetables using chained variable assignment. In other words, you are storing the same mixed vegetables or value for the soup into 3 separate Tupperware containers or variables, ready for when you start cooking. Remember that the separate ingredients no longer exist as individual vegetables, as they are now collectively being stored as mixed vegetables. We can see this if we were to print each Tupperware variable out in order to see what's inside using the print statement. As you can see, all 3 containers have the same new food value in them called mixed vegetables. While this works great for a soup where the ingredients mixed together become one ingredient, what if you wanted to keep the foods separate within the Tupperware container? Let's say you wanted to prepare your meals for the next 3 days. Each day you would eat chicken, salad, and yogurt. You don't really want the salad to mix with the chicken as it will make it soggy, while the yogurt is already in its own packaging. So to prevent them all mushing together, you go out and buy yourself some Tupperware that has dividers in it and place the chicken and salad each in a separate section. Next to them, you put in a yogurt tub and close the Tupperware container. Now you have 3 foods or values within the single Tupperware container or variable. You do the same using another 2 Tupperware containers. Now your meals are done and ready for the next 3 days. In Python, we can also easily do this by again using a chained assignment. The difference this time is that instead of only assigning 1 food or value to the 3 Tupperware containers, we are assigning 3 food values to 3 separate Tupperware containers or variables. Here's how you can do this. Tupperware 9 equals Tupperware 10 equals Tupperware 11 equals chicken, salad, yogurt. Using this method, we can now see that inside each of the variable containers, Tupperware 9, Tupperware 10, and Tupperware 11 are chicken, salad, and yogurt. The next day during lunch, you open the Tupperware and start enjoying your 3 food items. In Python, we would again use the print statement to open the lid in order to see the 3 food items inside the Tupperware containers. Please note that when using the print statement in this context, we aren't accessing each food item individually. Instead, we're opening the Tupperware to view all 3 food values simultaneously. In simpler terms, a print function merely lifts the lid off the Tupperware. It doesn't access the individual values within it. To access an individual item such as the salad, we would need to use a technique called indexing in Python. This is a bit advanced for this stage in the course, as I will cover indexing in more detail in a later chapter. For those who are interested, here's how we would write it in Python. Print, opening parenthesis, Tupperware 9, opening square brackets, 1, closing square brackets, closing parenthesis. In short, the 1 in square brackets is indexing the word salad within Tupperware 9. As I mentioned, I will go into more detail later on this topic, so don't worry about it for now if you don't quite understand. Fantastic work! Your fridge and kitchen are looking much more organized while you have prepared some delicious soup, as well as your lunch meals for the next 3 days. Let's continue to organize and cook in our Python kitchen. Dynamic typing is a key characteristic of many programming languages, including Python. In a dynamically typed language, you don't have to declare the type of a variable when you create it. Instead, the language automatically determines the variable based on the value you assign. This allows for more flexibility because a single variable can be reassigned to values of different types throughout its lifetime in a program. We will talk more about the different data types in the next chapter, so don't worry too much about that for now. Alright, let me explain how we can make use of dynamic typing in our kitchen. We already know that in Python, variables are like Tupperware containers that can hold different types of data. When we first create and assign a variable, we are essentially taking an empty Tupperware container and filling it with something. However, if we want to use the same Tupperware and fill it with something else, we can do that too, as Python allows you to assign a new value of any type to the same variable at any point in your program. Let's take a look at an example by using the Tupperware 5 container variable. Here's how our code will look. Tupperware 5 equals pizza. Print opening parenthesis, Tupperware 5, closing parenthesis. In this code, we assign pizza to the Tupperware 5 variable and then print its value. The output will be pizza, indicating that the Tupperware 5 container now holds the value, pizza. Here is where dynamic typing in Python comes into play. We can change what Tupperware 5 holds by assigning a different value to it. Here's how our code will now look. Tupperware 5 equals spaghetti. Print opening parenthesis, Tupperware 5, closing parenthesis. In this code, we now reassign the value of spaghetti to the Tupperware 5 variable and print its value again. The output will be spaghetti, indicating that the Tupperware 5 container variable has been reassigned with a new value, spaghetti. Therefore, Python's dynamic typing allows us to change the value and type of a variable freely. When doing so, it doesn't maintain a memory of a variable's previous type once it's been reassigned. Just like you can wash out a Tupperware and fill it with a completely different type of food, Python allows you to reassign variables with new values of any type. Remember, the value in a variable is only as good as the latest item you put in it, just like a Tupperware container only contains the last food item you stored in it. With this, you can always reuse a container or variable name for a different item or value. The flexibility of Python variables makes them an essential tool in your programming kitchen. As with multiple assignments, Python also allows you to reassign values to multiple variables all in one line, similar to how you would repack several Tupperware containers at once. For example, this is our initial multiple assignment code from earlier. Tupperware 1, Tupperware 2, Tupperware 3, Tupperware 4, Tupperware 5 equals carrots, apple, tuna, cake, pizza. If we now want to change the values assigned to each variable, we simply modify the food items in the respective order. For example, Tupperware 1, Tupperware 2, Tupperware 3, Tupperware 4, Tupperware 5 equals broccoli, banana, salmon, brownie, pasta. In this updated code, the values of the variables have been reassigned with different food items. Now Tupperware 1 holds the value broccoli, Tupperware 2 holds the value banana, Tupperware 3 holds the value salmon, Tupperware 4 holds the value brownie, and Tupperware 5 holds the value pasta. So as you can see, we can easily reassign single variable or multiple variable values at the same time in Python. We can again confirm these changes using print statements, which output the new reassigned values of broccoli, banana, salmon, brownie, and pasta instead of the original carrots, apple, tuna, cake, and pizza. Alright, this is going great so far. Now that we know how to assign a variable to a value using various ways in Python, let's start to organize the labels of our Tupperware containers. This is important because if we simply place food items into unlabeled Tupperwares, it's going to be very difficult to know what each container holds, which means that we need to open each one to find the food we are looking for. This isn't optimal, and we can definitely be more organized by putting a label on each of our Tupperware containers. This will then tell us exactly what food is inside without having to open them. Here's how we would go about doing that. First, we will use our previous multiple-line variable assignment code of Tupperware 1 equals carrots, Tupperware 2 equals apple, Tupperware 3 equals tuna, Tupperware 4 equals cake, Tupperware 5 equals pizza. Now, instead of using the word Tupperware as the label of each variable, we will instead use a more descriptive and meaningful label that represents the actual contents or value inside of each container. For example, instead of using a generic name such as Tupperware 1, we will instead change it to vegetables. We will then do the same by changing Tupperware 2 to fruits, Tupperware 3 to fish, Tupperware 4 to dessert, and Tupperware 5 to leftovers. With these changes to the variable labels, our code will read as follows. Vegetables equals carrots, fruits equals apple, fish equals tuna, dessert equals cake, leftovers equals pizza. Now, instead of using generic Tupperware containers as our variables, we write and stick a label on each one, effectively giving them new unique names. Remember that their functionality is still the same as before, as they are still containers that hold the food values we place inside them. We simply gave them better labeling to make our code easier to read and write. Let's again try this using the print statement and adding it to the end of our code. Using the print statement, we access or open the lid of the Tupperware container called dessert in order to see that there is cake inside it. These descriptive names simply make it easier to understand what each variable contains. It's like having a well-organized refrigerator where you can easily find what you're looking for. We can again do multiple assignment on one line as follows. Vegetables, fruits, fish, dessert, leftovers equals carrots, apple, tuna, cake, pizza. Print opening parenthesis, fruits, closing parenthesis. This time I chose to print the fruits variable, resulting in an output of the value assigned to it being apple. As we saw previously, you can choose if you prefer the single line assignment method or the previous multiple line assignment method. Again, either way works, so choose which you visually prefer. Awesome! Our fridge is starting to look much more organized. But, as with any fridge, there isn't only a single type of food in there. For example, carrots aren't the only vegetable in our fridge, as we will also want to keep various other vegetables such as spinach and onions refrigerated as well. To do that, we can also put all of them in the vegetables container together. Here's how our code will look. Vegetables equals carrots, spinach, onions. This is similar to what we did with chained assignments earlier when creating our prepared meals for the days ahead, except we are only doing it for a single container called vegetables and not multiple containers or variables at the same time. If we use the print statement, we can see that we get the same results as before. The output result from Python is opening parenthesis, carrots, spinach, onions, closing parenthesis. This is known as a tuple and is one of the Python data types. We will look into it in the future as well, so don't worry about it too much for now. Here again, the print statement is like lifting the lid of the Tupperware container. It only allows you to look inside, but not access the individual food values. To do this, we need to again make use of Python indexing, as I mentioned earlier. Alternatively, we can put the spinach and onions in their own Tupperware containers. We can do this by simply creating two new Tupperware variables, one per each line, and calling them vegetables2 and vegetables3, then assign the values of spinach and onions to them. Our code will then look like this. Vegetables1 equals carrots. Vegetables2 equals spinach. Vegetables3 equals onions. When printing each of these variables, we can see that when compared to the previous method, this one isolates each vegetable or value with a unique Tupperware container or variable, meaning that there is no sharing of vegetables or values across containers. Alright, this is definitely a better naming convention, but at the same time you might be thinking to yourself that naming the Tupperware variable as vegetable1, and then only placing a single value such as carrots in it can seem slightly silly. Wouldn't it be better to just label the Tupperware container as carrots if that's all that is going to be assigned to it? The code would then look like this instead. Carrots equals carrots. Print carrots. When printing this, we see that it does output the carrots value, indicating that this does functionally work in Python. However, you might see a small problem here. Now both the variable and the value are named carrots. While Python doesn't technically have a problem with this in terms of readable code, it's not the best way to go about it. The reason being is that it causes you to easily confuse the two as the same when they are not. Remember, the variable named carrots is the container and the value named carrots are the actual carrots. See how quickly it now becomes confusing. To solve this, I would strongly suggest differentiating them slightly by continuing to name the variable carrots, but then name the value something like carrot_slices instead. Our code would now look like this. Carrots equals carrots_slices, print carrots. When printing this, we see that it outputs the carrots_slices value instead, but this is now much easier to read and understand for both you or anyone else working on your code. You could also put the verb before carrots in order to create a value name such as graded_carrots. In other words, as long as they are not the same name as the variable, while keeping a descriptive to the value, it will work and go a long way to keeping your code neat and easy to understand. Alternatively, you have the option to rename the variable currently known as carrots to something different like graded_carrots, while maintaining the same value name, which is carrots. Here is how the code would then look. Graded_carrots equals carrots. Print graded_carrots. When printing this, we see that it outputs the carrots value, but as before, this is much easier to read and understand for both you or anyone else working on your code. Then, just in case you were wondering, we can add as many variables and values as we like in Python. Say, for instance, you went shopping and bought some new color-coded Tupperware containers in order to help make your kitchen foods easier to identify. Here is an example code where we would add more variables with assigned values while giving them color-coded variable names. We would use green Tupperware containers for all our vegetables, such as carrots, onions, and garlic. red Tupperware for all our fruits such as apple, banana, and orange. It also doesn't have to be 3 at a time either, as shown here with only 2 blue Tupperware containers used for the fish values. Desserts use the yellow Tupperware containers while the purple containers are for leftovers. Now you can easily identify not only what type of food is in the Tupperware by its color or variable name, but also its label or value. Note that these are again just names given to the variables. They have no actual influence on color. It's simply an alternative way for labeling them in relation to our example case, which is the Tupperware in our kitchen. If you were creating variables for another genre such as dogs, you would create variable names according to their breed, as an example. In summary, this practice of giving meaningful names to your variables is an important part of writing clear, understandable code. In the programming world, this is known as using self-descriptive or self-documenting variable names. You can name both your variable and assign values wherever you like, but in order to become a great coder, requires you to master the art of keeping things organized and easy to understand. It's a habit that will make your code much easier to read and maintain, not just for you, but for anyone else who might work with your code in the future. When creating names for your variables in Python, there are certain rules that you need to adhere to. Let's take a look. A variable's name or label can only contain alphanumeric characters, which include letters in both upper or lowercase, numbers 0 to 9, as well as the underscore symbol. For example, the following are correct ways to name a variable because both are created using only letters and numbers. Lowercase t for Tupperware, then an underscore, then an uppercase A and the number 1. Or uppercase T for Tupperware, followed by the numbers 1, 2, 3. Note that this example illustrates that you cannot have any spacing in your variable's name. In other words, it cannot be lowercase t for Tupperware, then a space, then an uppercase A and the number 1. If you want to create the illusion of a space, you need to make use of the underscore. Here is a table summary of what we just learned. It shows that a variable can contain upper and lowercase letters, numbers, as well as underscores, but it cannot contain spaces. The variable's label also cannot use symbols such as tilde, exclamation mark, @, hashtag, $sign, percentage sign, question mark, etc. For example, these variables are not acceptable because Tupperware $1 contains a dollar symbol. Blue underscore Tupperware contains an exclamation mark. Tupperware box contains a hyphen. Tupperware @1 contains an @ symbol. Here is another table summary, showing that we cannot make use of special characters when creating variables, except for underscore. While numbers are acceptable in Python's rules for variable naming, a variable's name must start with a letter or the underscore character. For example, these two variable names are acceptable because Tupperware A starts with a letter, underscore Tupperware B starts with an underscore. While at the same time, his variable name is not acceptable because 1. Tupperware starts with a number. Hence, a number cannot be the first character in a variable's name, unless it is spelled out in words. For example, the following two variables are acceptable because Tupperware 1 starts with a letter. 1. Tupperware starts with a letter of the word 1. Here is a table summary, showing that variables can start with a letter or an underscore, but cannot start with a number. Variable labels are also case-sensitive, meaning that these three variable names are acceptable and at the same time will also each create a unique variable, even though phonetically they sound the same. Here's a summary showing that variables are case-sensitive and therefore using different mixtures of upper and lowercase letters results in unique variables, even if they are spelt the same. Remember, while Python allows you to use any length for your variable names, it's considered good practice to keep your variable names relatively short and, more importantly, descriptive. For example, food underscore container is a better variable name than just SC because it tells you what data the variable is likely to hold. This again ties back into what I said previously about keeping your code clean, organized, and easy to read and understand for future purposes. To recap, here's a full table showing all the naming rules that need to be followed in order to create valid variables. I will attach this table as a separate image in this course's materials for you to look back on at any time. Great. Now that our variables are named and labeled correctly according to the Python rules, let's now take a look at case styles. While the Python naming rules are mandatory to follow in order for your code to work, the naming case styles are instead a set of best practice guidelines followed within the coding community. For Python, these guidelines are known as PEP 8, which governs and dictates the best practices for writing clean and understandable code in Python. In fact, there is an official website dedicated to PEP 8. By not adhering to PEP 8 guidelines doesn't mean that your code won't work, but it might be more difficult for others to read and understand. In essence, PEP 8 was established to create global uniformity among Python coders, making it easier for everyone to pick up and understand each other's code. With that said, let's take a look at the common case styles used in Python. Snake case is the most common case style when it comes to creating variable names in Python. Snake case gets its name because it consists of all lowercase letters, while using underscores in order to separate each word, making it look like a snake. For example, the variable name _sticks that we used earlier is an example of snake case. Here is another snake case example with an image to help you remember. The camel case is another favorite amongst coders. This style starts with a lowercase letter and capitalizes the first letter of each subsequent concatenated word, making it look like a camel's humps. For example, the variable name _S sticks is an example of camel case. Here is another camel case example with an image to help you remember. The Pascal case is similar to camel case, but it capitalizes the first letter of the first word as well. This style gets its name from the Pascal programming language, which uses this convention. Like a camel case, it removes spaces and each word is capitalized. For example, the variable name C _S sticks is an example of Pascal case. Here is another Pascal case example with an image to help you remember. Constant case is used for defining constants in Python as per the PEP 8 guidelines. Constants are usually defined on a module level and are written in all uppercase letters with underscores separating the words. It's a way of signaling to other developers that this value is a constant and is intended to stay the same throughout the execution of the program. For example, the temperature of boiling water in degrees Celsius can be represented as a constant. In this example, boiling _point_water Celsius is a constant that holds the value 100, representing the boiling point of water in degrees Celsius. Here is a table showing all the 4 case styles that we just learnt, including snake case, camel case, Pascal case, and constant case. In Python, you have the flexibility to utilize any case style for your variable names. However, maintaining consistency in your chosen style is beneficial. The official Python style guide, PEP 8, advises employing snake case for variable names and constant case for constants. Selecting meaningful and descriptive variable names is also an essential practice. Such names enhance the readability and comprehensibility of your code. For instance, if your program is related to categorizing apple types, you might choose variable names like golden_delicious_apple, granny_smith_apple, pink_lady_apple in snake case. You can then use these variables to assign a value for either their color by assigning golden_delicious_apple to yellow, granny_smith_apple to green, and pink_lady_apple to red, indicating that the golden delicious variety of apple is typically yellow, the Granny Smith variety is typically green, and the pink lady variety is typically red. Another way to go about this is to assign each variable to a taste such as sweet, sour, and tangy. For example, our code would then look like this instead. Golden_delicious_apple equals sweet. Granny_smith_apple equals sour. Pink_lady_apple equals tangy. Now each apple is assigned to its taste instead of its color. There are endless ways to go about creating variables in Python. These are just 2 example cases. In summary, these variable case style names clearly communicate what they represent within your code, which is the main objective. In Python, certain words are reserved for the language syntax and should not be used as variable names. These are known as reserved keywords or built-in names. Using these as variable names can lead to unexpected behavior and bugs that are hard to track down. For example, list and str are built-in names in Python. List is a built-in function for creating a list, and str is a built-in function for creating a string. If you were to use these as variable names, you would overwrite these built-in functions in your code. Here's an example of what not to do. List equals opening square bracket 1, 2, 3, closing square bracket. Or str equals opening double quotations, hello world, closing double quotations. In this example, list and str are no longer available as their original built-in functions. Therefore, if you try to use them as such, later in your code, you'll get an error. To avoid this, you should never use reserved keywords as variable names. While you can check the Python documentation to see which keywords are reserved, most Python code editors will know about these reserved keywords already by highlighting them in a different color. You can see in our examples here that they are highlighted in green, indicating to us that they are reserved and should not be used as variable names. If we simply change them to a non-reserved variable name such as my_str and my_list, then they change back to white, indicating that they are safe to use. Alternatively, you can also use and run this line of code. Help, opening parentheses, quotation mark, keywords, quotation mark, closing parentheses. This will conveniently output all the reserved keywords for you right in your Python editor. In conclusion, variables are essential components in Python programming that enable us to store, manipulate, and access data. They function similar to storage containers, holding various types of information within our programs. You can create them, assign values to them, change those values, and access the data. The dynamic typing feature in Python allows us to assign values to variables without explicitly specifying their types. This flexibility grants us the freedom to reassign variables with different values and types throughout our code, providing versatility and adaptability. By employing meaningful and descriptive names for our variables, we enhance the readability and comprehensibility of our code. Adhering to naming rules such as starting with a letter or underscore and avoiding special characters or spaces ensures that our variables are valid and conform to the Python syntax. Choosing an appropriate case style, whether it's snake case, camel case, or Pascal case, contributes to code consistency and improves code maintainability. Consistent naming conventions facilitate collaboration among developers and make our code more understandable. Multiple assignments allow us to assign values to multiple variables simultaneously, streamlining our code and reducing redundancy. This technique is akin to packing several storage containers at once, saving time and effort. Accessing variables is straightforward, as we can retrieve their values simply by using their names. We can modify the contents of variables by assigning new values to them, just like replacing the contents of a storage container. When doing so, Python forgets the previous value and adopts the new one. Understanding variables and practicing proper variable management is crucial in Python programming. It empowers us to store and retrieve data efficiently, make decisions based on the values stored, and create dynamic and interactive programs. By following best practices, including using descriptive variable names, organizing variables with labels, and maintaining code consistency, we produce clean, readable, and maintainable code. These practices promote code understanding, ease debugging processes, and facilitate collaboration among developers. As we progress in our Python journey, exploring different data types and structures will further expand our programming capabilities. We will unlock the potential of the vast Python ecosystem by utilizing its tools and libraries to solve complex problems and build powerful applications. In the next chapter, we will dive into different types of data that we can store in these variables, just like how we store different types of food in our storage containers. We'll also learn about different data structures and object types in Python. And that brings us to the end of this video. If you've made it this far, I sincerely hope that you enjoyed the content and have learned something new. If so, please leave a like and subscribe if you have, as well as to get notified of any future videos. Oh, and make sure to check out this video as well. You can also subscribe over here. And this one is pretty cool too.